Hello ladies and gentlemen, my name is Mr. Dotson-Kelly. I am an Algebra 2 teacher at East Hartford High School, and today I'm going to teach you guys how to divide rational functions. This first frame that you're going to see here is going to be a list of steps on how to divide, and then we are going to see an example. Step number 1, you want to factor each numerator and denominator completely. Step number 2, you need to determine which input values make denominators and the divisor equal to 0. The divisor is the fraction after the division symbol. The reason we want to find this out is because it is illegal to divide by 0. So if the first fraction was divided by 0, that's unacceptable. If the second fraction was divided by 0, that's unacceptable. If the second fraction equaled 0, that is also unacceptable because then we would be dividing by 0. Step number 3, you're going to keep the first fraction looking the exact same. You're going to change the division symbol to multiplication, and you are going to take the reciprocal of the divisor. Again, the divisor is the fraction after the division symbol. I tell my students every year that dividing is mathematically equivalent to multiplying by the reciprocal. Step number 4, cross cancel. At this point, most likely, there have been some factors that are the same. So just like in my multiplication video, you will have an opportunity to realize that there are certain values in the numerator and the denominator between the two fractions that are the exact same within the parentheses. Whatever these are, you can cross cancel them because they are dividing to 1. You want to multiply the remaining numerators together and the remaining denominators together the same way you would multiply any fraction. What a lot of teachers say is multiply straight across. If you haven't done so already, please take a moment to pause the video and write down each of these steps in your notes. Now let's see an example. In this example, we are going to follow the steps I gave you guys. So step number 1 is to factor the numerator and the denominator completely. So the numerator, y squared minus 36, has two components. We've seen this happen a couple times. You might not recognize it yet, but we have here something called the difference of two perfect squares. What that means is that this right here is 6 squared, and this right here is y squared. And for that reason, I can write this out as y minus 6 times y plus 6. For those of you guys who are still not comfortable with the difference of two perfect squares, you can always rewrite it looking like this: y squared plus 0y minus 36, and ask yourself the question, what multiplies to negative 36 but adds to 0? And the only way that we can multiply to negative 36 and add to 0 is by having a positive and negative 6. So this right here is the factor of the numerator of this first fraction. We are now going to go ahead and find the denominator of the first fraction, which is y squared minus 8y plus 16. Again, we are going to ask ourselves the question, what multiplies to 16 but adds to negative 8? And so by writing down the factors of 16, 1 and 16, 2 and 8, 4 and 4, we will notice that 4 plus 4 is 8, but we want it to be negative 8. So if we instead chose negative 4 times negative 4, which would be negative 4 plus negative 4, I would then get negative 8. So my factored form for this would be y minus 4 times y minus 4. I now want to analyze my second fraction, which is going to be 3y minus 18. This is a linear polynomial. So what I can do here is I can factor out a GCF, recognizing that both 3y and 18 are factorable by 3. The GCF of 3y and negative 18 would be 3 times y. This one would be negative 1 times 3 times 2 times 3. And what do these two have in common? They both have a 3 in common. And I can factor that 3 out. So this would become 3 times y minus 6. The 6 I'm getting from negative 1 times 2 times 3. So that is the third polynomial. And then last but not least, the y squared minus y minus 12. I'm asking myself the question, what multiplies to negative 12 but adds to negative 1? So I'm going to write out a list of factors. Negative 1 times 12, negative 2 times 6, negative 3 times 4. And then I'm going to do the opposites of these. 1 times negative 12, 2 times negative 6, and 3 times negative 4. If I were to find the sums of these, I would find the only one that works is this one. 3 plus negative 4 is negative 1. Pause the video and verify that the other ones do not add to negative 1. So what this becomes, using these as my factors, I would then have y plus 3 times y minus 4. I now have all 4 of these polynomials factored. So y squared minus 36 becomes y minus 6 times y plus 6. Y squared minus 8y plus 16, which is over here, would become y minus 4 times y minus 4. 3y minus 18 is going to become 3 times y minus 6. And last but not least, y squared minus y minus 12 is going to become y plus 3 times y minus 4. And so I'm going to take all four of these results and rewrite my original problem. So this was step 1. I need to rewrite that fraction. So that fraction is going to become y minus 6 times y plus 6 divided by y minus 4 times y minus 4 divided by 3 times y minus 6 divided by y plus 3 times y minus 6. And that right there, ladies and gentlemen, is step number 1. Step number 2 is going to be our restrictions, our constraints. What makes our denominators equal to 0, and also what will make my divisor equal to 0. So I need to know what makes y minus 4 times y minus 4 equal to 0. I need to know what makes y plus 3 times y minus 6 equal to 0. Sorry, this is y minus 4. And last but not least, I need to know what makes the divisor equal to 0. The only way the divisor can equal 0 is if my numerator were to equal 0. So what is going to make 3 times y minus 6 equal to 0? So these are the three things I need to solve for. All of these are going to utilize the zero product property. In order for any of these to be true, one of the factors needs to be 0. So here, because I end up with the same factor twice, I'm just going to write this out, y minus 4 is equal to 0. Over here, I have to separate this. Y plus 3 is equal to 0, or y minus 4 is equal to 0. And last but not least, over here, y minus 6 will equal 0 because 3 can't equal 0. Solving these really quickly. So these are my constraints. Y equals 4 shows up twice. So my constraints are, I can use any input value of y except for 4, negative 3, and 6. And the reason I can't use those is because it is going to give me an undefined result, whether it's dividing by a 0 here, dividing by a 0 here, or dividing by a 0 here. Sorry, this was step 2. Step 3 was to keep the first term and then multiply by the reciprocal. So that means it's going to be y minus 6 times y plus 6, all divided by y minus 4 times y minus 4, multiplied to the reciprocal of the divisor. So that's going to become, instead of y plus 3 and y minus 4 in my denominator, it is now going to be my numerator. Y plus 3 times y minus 4 with the 3 times y minus 6 in my denominator. This allows me to now do some cross-canceling. Y minus 6 is both in my numerator and my denominator, and now I'm moving on to step number 4. Step number 4 is my cross-canceling. These become 1. Additionally, I can do that one more time with this y minus 4 and this y minus 4. So this is going to cross-cancel with one of those. So this becomes 1, and this becomes 1. And so now what am I left with? In my numerator, I'm left with 1 times y plus 6 times y plus 3 times 1. So this is going to become y plus 6 times y plus 3, all divided by, in my denominator, I have y minus 4 times 1 times 3 times 1, and that will become 3 times y minus 4, with the constraints that y cannot equal what I have up here, which was negative 3, 4, and 6. And that is my final answer. Thank you, ladies and gentlemen, for watching my video. I hope this helps. Stay healthy and stay safe. Thank you.